Hello, so today you're going to be doing a lab on your first lab using Eagle schematic creation tool, which is will also allow you to create a printed circuit board layout that can eventually be built. And the lab things that you're going to learn today, or you're going to learn about the landscape of electronic design tools. Just a quick introduction to that. Try to develop a method for creating a PCB, sort of a recipe, how to locate parts that you're going to use on your board, and then how to create a schematic in Eagle using custom or preloaded libraries. So your goal shall be in this lab to create, more or less, you're going to create this schematic. You're not going to cut and paste this, you're going to create it yourself, and then you're going to put it in a Word document and save that in Moodle. Okay, so let's start with this, getting a lay of the landscape. So this is a very rough overview of the electronic design tools that you may or may not have had experience with so far. And I labeled the three different criteria, or three different properties of each of the electronic design tools in terms of whether they can create schematics, whether they can simulate the circuit, and whether they are able to create a printed circuit board layout that can eventually be built. So some of you have played with National Instruments Multisim in your circuits class. National Instruments Multisim, as you know, you can enter a schematic. And by a schematic, I mean you're laying down symbols that look like this. They represent, like this represents a resistor, this represents a capacitor, and so on, a transistor. In the layout world, you don't necessarily see the transistor. You might just see two pads that are eventually connected to wires. And then the resistor itself would be inserted in here if there were holes drilled in the board and soldered. A capacitor would look identical. It's just a two-hole or a two-pin device. So all you'd see on the board are two pads. And a transistor might have three pads. So this would be the schematic view. This would be the layout view. And in Multisim, once you create your schematic, put on a whole bunch of resistors and power supplies, you are capable of simulating it in various ways. You can do DC simulation, you can do AC simulation, and you can do what you might call transient simulation. So there's a whole area of electronic design tools that involve simulation. And then when you're all done with the simulation, if everything worked the way you expected, you would go and create a layout, which Multisim can do. I believe it's a software package called Utiliboard. But again, you can do all three elements of design. So what we're going to be using today is Eagle. Eagle is great about creating schematic. You can easily create a schematic. You cannot do simulation with Eagle. So that's not what it's for. And it is very good at creating printed circuit board layouts. Actually, it's quite a bit better than Multisim at creating a layout. It's a lot easier to use. Another free tool is called OrCAD, and this is from a company called Cadence. And it's you might say this is a more sophisticated version of Multisim. It's quite a lot more features to it, and it again can do all three design elements. And then the other software package that we're going to look at in here is ExpressPCB. ExpressPCB is useful for creating schematics and printed circuit boards, but again, like Eagle, it cannot create a simulation. Okay, so that's where we are. We're going to use Eagle. So now we're going to develop a methodology for creating a circuit board. And the first thing that I want to do before I start, really the goal is to create a layout. I mean, that's my goal. So before I do that, I'm going to have, hopefully, have created a schematic that reflects something that I actually built. So I've got this on a breadboard. So somewhere on a breadboard, I've created this circuit. And this happens to be a Schmidt trigger. It's got a power supply. It's got a transistor. And 3 resistors. And I also want to have some sort of a connection off the circuit board. So I've got these connectors. All right, so this is going to be another feature. I've labeled some of the nodes, like V out, voltage out, V out here. These are connected. It's a virtual connection, but when I actually build it on a board, there will be an electrical connection between V out and V in. I have not drawn them in here because it's much more convenient sometimes to connect things virtually rather than by drawing an actual line on the schematic. I need V out, V in, and I need a ground connection off the board. If I'm going to look on a scope, I need to connect the ground to something. So this ground node needs to be the same as this. Again, these are connected. I just didn't show the actual wire. So in your methodology, you first want to have a board such as this. Okay, you want to have created a schematic sort of on a piece of paper somewhere before you actually start using Eagle. Okay, and I've got some sense of what I want to use for these devices in terms of the actual physical device in my hand. I kind of know what I want to use for this op amp. I know what I want to use for these connectors and these resistors. These resistors are like the kind I would have in lab. These things would be, you know, roughly 10 millimeters apart. The pads would be roughly 10 millimeters apart, so that on my circuit board I'd have 2 holes like this, and I could work with that. This would be, you know, say 10 millimeters. So when I was done with that, I'm ready to go to Eagle. So I'm going to go, I've got it open here, but you guys should be able to find this on your school computers. All programs, Eagle, and if you're downloading this at home, you want to use the free version. And now I'm going to do File, New, Schematic. Later on, I'll be doing boards and libraries, but right now I'm just creating a schematic. Okay, this is my design space. I've got a bunch of tools over here I can use, and we'll learn about what some of those are, but these are basic design tools: rotate, flip, erase, delete, so on, copy and paste. So what I want to do now is start laying down these things that I'm going to create. So for the battery over here, I didn't say this is. Let's just say I want to use a AA battery. So that's the first thing I'll go find. So my Add a Parts tool is over here on the left. And it looks like an AND gate. This is a list of, these are libraries, and within each library there are many parts. So you kind of have to know what you need. So I need a battery. So let's go look at batteries. I want a AA battery. CRAA, that looks right. So I'll use this as a AA battery. It's a 3 volt double A battery. So this is the layout view. This is what's going to be put on a board. This is how it's going to look in my schematic. So in Eagle parlance, this is a symbol and this is a package. So in my schematic, all I'm going to see is the symbol. Okay, now I want to rotate this one. So I'm going to go over here to the rotate tool, left click on it, then come out here, click on my device, and it rotates it. So my positive node is up. So I'll put in all my parts first before I start trying to connect nodes. Now I need my resistors. And I just happen to know that my resistors that I can use are under a library called RCL. And I've got a bunch of R's down here. There's R's that use European kind of symbol. And you can see that the symbol stays the same for each one of these. The package keeps changing. So this is the European symbol. We'll use the US symbol, which is the squiggly line that you're familiar with. And I just know that over here in my description, there's 204/5. These are 5 millimeters apart, 7 millimeters. I'm not sure what that one is intended to be, so the resistor is vertical. 7, 10. So I'll use this one, roughly 10 millimeters apart. It'll give me two holes that I can easily work with. So I need 3 resistors. So I don't need to do anything. I'll just put them down now, like that. Now I need a transistor. Sorry, not a transistor, an op-amp, ELT1052 in a dip package. And what I'll do is search for that. I'm going to do op-amp. Now I've got all the different op-amps. This search tool is okay, it's not great. Okay, what did I say? 358. So I'm scrolling down here for something that looks like a 358. Okay, there's a 358. And there's 3 different varieties of 358. This is a surface mount, hard to deal with. These are much smaller than they look here. These are identical. And then the DIL08 package is the one I want. This is the one that I'll be able to work with on my breadboard. It's going to give me 2 op-amps in this one chip. I only need to use one, so the other one will just be left hanging. So if I put this down, there's my op-amp. And now I want to have on and off chip connectors. And I know what connectors I need to use. These are ones that are in the lab. They're called Phoenix. That's the library, -500, and the actual device is MSTBV2. If I need to get back to where I was, I'm going to put a space here, and then hit this X, and it should refresh my list. So I need a Phoenix 500 MSTBV2. Looks like this. That's the one I want. So they each have two pins, so I only need 3, but I'm going to have to get 4 just because I'm rotating it now. I'm going to have to get 4 because of the because I need 3. 1 is just going to be left hung over. Okay, now I'm going to move these resistors so that 2 are vertical. That's my voltage divider. So I did the rotate tool. Now I want to move. If I want to move several things at once, I have to select them first. So I go to the select tool, select those 2. Don't click again. Now I go to the move tool. Now I come out here, right click, move group, and now I'm moving both. So it's a little different than probably what you're used to. Delete tool, cut, copy. So if I wanted to make more of these, I would hit the copy 2 guys here. Okay, delete. Copy, paste, mirror. If I wanted to mirror this, and so on. Okay, now the next thing I'm going to add here, this is critical a lot, and it's not necessarily that you need it in your circuit board, but it's absolutely the right practice. I need to add a ground, so I'm going to search for a ground in here. So I got 2 different symbols for that. I'll just use this one. And I need a VCC, sort of indicating where my power is. Every circuit needs to have this node labeled. These are going to be nodes. Okay, so now I've got all my parts in here. Now I am ready to connect them with a net. So a net, the net tool is down here on the left. Drag it over. And when I do that, I'm ready to create more or less wires indicating what's connected to what. Do I want to connect N3 to ground? Yes. Okay. So oops, I did something wrong here. I don't want this connected there. Yes, I do. But I also want this. Now I want to create an input. So I'm just going to create a small net here. So make sure I can see some green. Now I'm going to name it. I'm going to name that net. So if I want to find out what the name of, for instance, this net is, I would click on the eye over here. And I click on this and it says name of this net is N$2. So it's sort of automatically named. But I want to force the name of this net to be VN. Okay, I can't see that yet until I do the label tool. So I want to label this net now, so I just left click on that. When I click on this net now, it's showing me the label, VN. If I wanted to see the label for this node, what was it, N3 or N4? Okay, so I don't necessarily want to label those ones, just the ones that I force a name. Actually, this is going to be my VOUT node. So I want to force this name to be VOUT. And I want to show it. So that reflects this VOUT and this VIN. Okay, now I want to connect this VOUT to one of these connectors. So I'm going to create a small net. I'll do one here too. And this will be my, I'll use these two for ground. Now I want to name this one VOUT. Do I want to connect them? Yes. This one should be VN. And this is going to be ground. And all I need to do to connect it to ground is copy this ground symbol over here, which I will do. So a copy. Yes. Now it's connected to ground. And now I want to show the labels for each one of these. VOUT, VN. These are now connected to these virtually. If I want to see what's connected to what, I'm going to go to the eyeball tool up here, click on it, and when I tap the node here, you can see it's toggling the VN. It's telling me they're connected. When I click on the ground, this ground is connected to that. V plus. Okay. So now I'm ready with my schematic. My schematic is all done. So what's your job after watching that? Well, is to create your own schematic using this diagram here. And I've indicated where you should find the various parts for this schematic in the lab write-up. So the library is under RCL here. The battery is here. This power supply is under the library battery, and so on. So this is a bill of materials. How can I create a bill of materials for this circuit? So first of all, I'm going to save it. And I'm going to save this on my desktop, and I'm going to call it my first schematic. And first of all, I want to create a folder in here, so I'm going to create a new folder, Lab 5, for example. And I want to save it in Lab 5, my first schematic. Now I'm going to create a bill of materials, so it's going to give me a list of all these things. And it's going to be under File, Export, Part List. And wherever I created that, my Lab 5 parts. Okay, so now it's saved. Let's go to my parts file and see what that looks like. Lab 5 parts. I'll open it with Notepad, and there it is. There's my part list, battery, my libraries, and my values, and so on. So this is all I would need to recreate this. So you have this list in your document. That's the one you're going to create. So what else might I want to export from Eagle? Okay, I might want to copy this into my document. So in that particular case, I'll do File, Export again, Image, and I want to export it to the clipboard. Okay, and now I can go and paste it into my document. Control V, there's my new. Rather than do a screen capture, you can do that in Eagle. Under Export, File, Export, Image. Okay, the last thing I wanted to show you was how to use a library that is not listed in the automatic installed libraries that are here. Okay, in this particular case, let's say I've created a custom library and it's called VTClib and it's saved, for example, somewhere in one of my let's say it's in my PCB materials. It's called VTClib and it's located under this directory. So what I would do is, back in Eagle, I would say library use, and now I have to go find it. It's on my desktop. VTClib, and then open. Okay, nothing happened until I go to the parts list, and now I've got all my original libraries, but now I should see a VTClib, and there it is. And I've got all these parts in here that I sort of have created for one reason or another. Okay, so I think you have everything you need based on that video to go in and do this lab. So good luck.